Thank you, Ashley Wisse, for joining us today. So excited to hear about this project. Ashley is the Director of Green Building Services at New Ecology, based in Boston, but Ashley's joining us from upstate New York. Ashley has managed the design, construction, and renovation of high-performance multifamily affordable housing at New Ecology since 2012. She oversees a team of project managers and energy raters and provides technical guidance to meet and exceed standards such as Passive House, LEED, Enterprise Green Communities, Energy Star, and Zero Energy Ready Homes. Passionate about innovation, she reaches new technologies to advance sustainable building practices. Ashley has also taught construction management at Wentworth Institute of Technology and holds degrees in civil engineering from Syracuse University and architectural engineering from Penn State. Ashley, thanks so much and take it away.
Thank you. Thank you everyone for attending today. The project I'm going to talk to you about is actually not a Passive House certified building, but it uses a lot of the Passive House principles. And it was the first net zero carbon multifamily retrofit in New York State. And I will talk through today some of the funding sources, as well as the project background, the scope of work, the equipment we chose to use, a little bit of overview in the construction, testing, and verification, and the results and future plans. And I know the chat is open for questions that will be asked at the end, so feel free to type your questions in there. So I work for a company called New Ecology. There's a little bit about that in my overview. New Ecology is based in Boston. We also have offices in the Mid-Atlantic, and we primarily serve affordable housing projects. So our goal is to make communities and affordable housing as sustainable, energy efficient, and healthy as possible. I've worked at New Ecology since 2012, rounding out my 13th year here, which is a little bit insane. I didn't know that I would be here this long, but has definitely given me a ton of experience in rating systems, program development, and overall management of these projects. So funding sources, obviously everyone wants to know how we pay for these projects. And at the end of this presentation, I'll give you the full details on the total cost of the project and the overall funding received. But this project was initiated back in 2019. The first round of the New York State Buildings of Excellence program had happened, and the second round was open for applications. And I was really interested in finding a building that would fit within the Buildings of Excellence requirements and would be able to be a challenge for all of us to really stretch our knowledge, create the best building we could, improve an existing building if possible, and benefit the people living in that building. And so Colonial II is owned by the Rome Housing Authority, as well as a partnership with Beacon Communities. And I'll get into the details of the building, but essentially Colonial I is its sister building right next door. And that had gone through an energy upgrade, mostly of in-kind replacement. So they did upgrade the envelopes, but they upgraded the mechanical systems with in-kind. And so this was the next building on the docket to be redone. And so it was at the right place at the right time to apply for this program and to become a very energy efficient building. For those not familiar with the NYSERDA Buildings of Excellence program, this started in 2019, and it has provided $83 million towards projects over the last 6 years. Right now, we're on the 6th round of competition, which is actually due today at 3 p.m., which I know some of you may be involved in. It awards buildings, both new construction and existing buildings, depending on the level of effort in the project and the amount of the cost of the construction, the amount of work being done. You can be awarded different amounts of money. Our project in particular was awarded the maximum amount, which is $1 million. And in order to do so, we had to meet a list of requirements. So we had to show at least 20% energy savings when using the ASHRAE 90.1 modeling. We had to do a low carbon and renewable energy project, advanced clean energy technologies, including fully electrified and energy recovery. The project needed to be replicable. This couldn't be a building that was so unique that the lessons learned from it could not be applied to other buildings throughout the state. We needed to address climate change, resiliency, and passive survivability. So making sure the equipment was placed properly to deal with any resiliency issues. We needed on-site renewables, the potential for sheltering in place. We also had to maximize our sustainability, prioritize occupant health and safety, and make it beautiful, architectural and urban design quality. And then they have bonus categories, and our project utilized building within a clean energy community, which was already a designation given to Rome, New York, a low and moderate income building. And they had a list of gut rehabilitation criteria that needed to be met. Additionally, we utilized NYSERDA's new construction incentives. And I know this wording is really tiny, but you don't need to know the exact details of this. The main information here is that there's 4 tiers available to new construction projects. And because this was a major renovation, we'll get into the details of how much was actually changed in the building. We had to fit into the new construction incentives program. And in order to achieve tier 4 rebates, we needed to show at least 30% energy savings via source energy before PV, and at least 40% source energy savings with PV. And so our project, using our ASHRAE model, actually showed a 33% savings as compared to the baseline. The ASHRAE model itself is a little bit of a sore subject for our project. We had a lot of issues with the modeling, and when we first applied to the Building of Excellence program, our calculations actually showed a 74% energy savings, which was fairly impressive, and we were all really excited to see that play out. Unfortunately, in the year and a half between that originally preliminary design and when we applied for the design level rebate from the Buildings of Excellence program, the calculations had changed, the formulas had changed, the baseline had changed, and the way we report out from ASHRAE modeling had changed. So all of the same inputs went into this new version of the ASHRAE modeling and showed 33% energy savings. And so same building, nothing changed with the design. We were still designing a really energy efficient building, but the percent savings shown via calculation dropped down to 33. Now, throughout that whole process, we were always net zero. So we always had a goal to offset the entire electricity used through the year and be 100% offset. So regardless of how we calculated it within the ASHRAE platform, we were able to make up that deficit using on-site and off-site solar. So how did we choose what to do? You know, we wanted to go for this Buildings of Excellence program. We wanted to comply with the new construction program, and we had to choose exactly what we wanted to include in our scope of work. As we mentioned, it's located in Rome, New York. This was already designated as a clean energy community. It's a mid-size community for the state of New York. And as I mentioned, it was the next in line to be redone and kind of right place, right time for this endeavor. So what were existing conditions? We had a building that was originally built in the 1970s as a school and dormitory. It was converted to housing in the 1980s and was really small units, 99 studio and 1-bedroom units, serving the low-income aging population, a mid-rise building. It had gas-based heating, and it was owned and operated, as I mentioned, by Rome Housing Authority. In order to comply with the HUD requirements for this building, we needed to reduce down the number of units to 74 and increase the unit sizing to meet the applicable HUD requirements. So essentially, every non-load bearing wall inside the building got demolitioned and rebuilt in order to fully change all the layouts on every floor of this building. It was still going to serve low-income aging population. The exterior was going to remain mostly the same, but you'll see that we did add some insulation on the exterior. Again, we are going to comply with the Buildings of Excellence requirements. We were shooting for NGBS Silver certification, as well as ASHRAE Energy Star certification being the ASHRAE path, and we're going to convert it to an all-electric building. So its sister building, Colonial I, nearly identical, almost the exact same number of units, very similar systems, very similar layout, was completed in 2019. That project included upgrades to the exterior envelope, systems upgrades to match the efficiency of the available equipment at that time. However, it did not include cooling. We didn't add in cooling. It did not have a ventilation system. It still had that gas-based equipment. It did achieve NGBS Silver certification. And via the TREAT modeling, the Colonial I building showed about 7% energy savings over baseline, which was not going to be sufficient to get us to the Buildings of Excellence requirements. So we took that scope of work and adjusted it for Colonial II. We added cooling to the building, we added ventilation to the building, electrified the building, and we used ASHRAE modeling to get over that 30% minimum requirement energy savings to show 33%, and then added on the net zero carbon component by using renewables on site. So our envelope design, we had an existing building that we had to work within the constraints of that existing building. And at Colonial I, we had essentially maxed out the available space and structural requirements to upgrade the envelope. So we more or less had to do the same envelope at Colonial II. That left us with an R32 wall using EFIS on the outside and cavity insulation, an R54 roof, and windows with a U value of 0.28. And again, these were more or less the same as Colonial I, but required given the constraints of the existing building at Colonial II. And here's where the two projects really start to diverge. So we added ventilation to Colonial II. You know, we're adding all of this air sealing, we're increasing the insulation in the walls, we're putting in new buildings. We want to make sure that that air inside the building is still healthy and fresh and being exchanged for those residents. And so we considered both central ventilation and individual ventilation. And pretty quickly, we realized that we were limited to unit-based individual ventilation equipment. A central system would have required significant changes to the building layout. We would have had to add soffits in all of the hallways and in the already fairly small unit spaces. And so we opted to go with these individual through-wall ventilation equipment. We did use MERV 13 filtration to ensure that we were getting the healthiest air possible into these units. And this was actually developed during COVID-19 when there was a strong desire to separate all air from living spaces and not necessarily have central ventilation systems. Our domestic hot water design used a electrified sand and heat pump water heater. This allowed us to have a recirculation loop, which minimized the heat loss in the piping, but also minimized the time to service. So when someone calls for hot water, we don't want to be waiting there for a minute for the hot water to get to our units. We want it to get there quickly so we're not wasting water and we don't have complaints from the building users. Our heating and cooling system, we had two viable options. We had a variable refrigerant frequency, or VRF system, as well as the geothermal with ground source heat pumps. Both of these systems, the energy model savings were fairly similar, mainly because the limitations of the ASHRAE software don't really allow us to fully realize the energy savings from the ground source heat pump system. But our final decision really came down to carbon reduction, refrigerant reduction, integration with the solar PV, and the highest efficiency equipment possible, as well as, of course, pricing. And so we opted to go with the geothermal system. And that was primarily given we had space to do geothermal, and we also wanted to optimize the sustainability as much as possible. We did consider using a solar thermal system, but we were not able to make this work with the space constraints and structural requirements of the existing building. So this is a layout of the site. So you can see up in the right-hand corner, that's the Colonial II building. In the center of this layout is actually the Colonial I building. And then this area where we see a solar field and the geothermal wells was actually owned already by Rome Housing Authority and underutilized. It wasn't really providing space for the units or for the occupants. There's a lot of other green space with picnic tables and areas for them to utilize. This was just kind of barren land. And so it was the perfect place to put our 34 500-foot deep wells, closed loop wells for the geothermal system, as well as a ground mounted solar system to offset the energy use. And we did a lot of scenarios. We had solar over the parking, we had solar on the roof, we had solar on the roof of Colonial I. And this really allowed us the maximum solar layout to offset our use and made the most sense for this project. Speaking of solar, in order to get to that net zero offset, we had to combine both on-site solar as well as purchase of off-site community solar. And in order to make that work, we actually had to divide the building into 2 meters so that we had a meter that was connected to the on-site solar and a meter that was connected to the purchase of off-site solar. And so 1 meter, we had basically had to take all of the equipment in the building, understand what each piece of equipment was going to use, and connect them together so that we had an aggregate use that was approximately equal to the solar offset on site and approximately equal to this purchased solar offsite. So 1 meter included apartment plug loads, appliances, lighting. The other meter included HVAC systems, common area plug loads, domestic hot water, and other usage. So you can see some of the calculations that went into that. We had the modeled usage month by month in kilowatt hours, and then we had to divide that into the solar offset to match up the solar in the on-site community or the on-site solar field, as well as the community solar, further complicating some of our future data organization, which I'll talk about at the end. So we have this amazing design, everything is ideal, and now we actually have to do the construction. Making the construction even more complicated, this was an occupied building. We had 4 vertical stacks that were constructed one at a time, with people living in 2, sometimes 3 of the other stacks while the construction was happening. So we essentially had to take off all of the exterior walls in one stack, put enough back on that people could live in that space while we moved on to the next one. And then we had to turn on the geothermal system in shifts. A lot of this had to be done in a phased approach. And because of that scheduling, we actually weren't allowed to sample any of our verification or testing items. So we tested every single unit in this building for blower door testing, duct leakage testing, water use testing, all of those items to make sure that we were meeting all the thresholds of Energy Star and NGBS. So we really had to make sure that we were all on the same page. We had a culture of trust with the people building the building, and that everyone understood what the common goal here was. We didn't have a chance to go backwards, right? Once we finished one stack, we had to move to the next stack, and the lessons learned from stack one could be applied to stack two, but we couldn't go back necessarily and fix. So there was a lot of education on site. We did a lot of training seminars to make sure that everyone understood what was going to be tested and inspected and why those things were important. Why did we need to have a grade 1 insulation on the exterior wall? And what happens if it's not grade 1? Why is that a bad thing? Why do we need air sealing, and how are we going to test those units so that the people installing the air sealing material really understood what was going to happen at the end of construction? So it was a very hands-on and educational construction site. Obviously, we then had to measure all the performance lift by lift for the roof insulation, confirming that we were meeting all of the thicknesses and R values. Same for the piping insulation, and confirming all of the water use fixtures were what was specified and what was calculated in our water use savings calculations. And lastly, we had to do a blower door test in every single unit to make sure that we are hitting the applicable thresholds of Energy Star and NGBS. This photo I really like. This is actually the code officer who wasn't familiar with blower door testing when he first came out to site, and then was very interested in learning everything. He wanted to understand what the output was showing on the screen, how we were doing the test, what the thresholds were, how to calculate compliance. And by the end of the project, he was a blower door expert and was interested in purchasing his own blower door so that he could help projects do better in the future. So we got through design, we got through construction. Now what? We now have an NGBS certified building. We have an Energy Star certified building, which is great. And I'm sure everyone wants to know the money part of things. So this building cost nearly $40 million. And it was essentially on par, as I mentioned, with new construction projects, right? You know, we moved almost every building on the interior, we rebuilt the exterior, we replaced every piece of equipment. For all intents and purposes, it was a new construction within an existing framework. This project was actually about $3.3 million over budget, which was a 12% increase from our initial budget, primarily due to delays during COVID. Things actually either weren't available and we needed to pay more to get different equipment, or just the cost of equipment in general also increased during that time. That was about $371 per residential square foot. We did calculate what NYSERDA calls the performance-related costs. So $14.6 million were what would be going above and beyond. So if you take what you would have done without going for the Buildings of Excellence, without kind of maximizing the efficiency, we had that cost. And then this was the differential to get us to the net zero building, the super high performance, the addition of my time and other soft costs related to confirming that sustainability. We had the $1 million from the Buildings of Excellence program, as well as $450,000 from the new construction program. We also had numerous tax credits from LIHTC, as well as the renewable energy tax credit. And according to our models, we had about 14,600 savings annually before solar offsets. And so now what we're working on is tracking that, tracking the data, tracking the costs, understanding, is what we saw in that ASHRAE model actually happening? How does that compare to the model versus what we're actually seeing? How does that compare to the Colonial II building that was done more of a replacement in kind? what's the difference in annual fees there? And we're in the middle of this calculation. We need to drill down a little bit more into the data. With the 2 meters set up, it is a little more confusing. You get a lot more bills. And the demand charges at this building are really high. So we're working with the owner to do what we can to potentially reduce down those demand charges. So I know that was a ton of information, but I tried to stay within the time limit. And if you want to learn more, we did recently publish an article in the NYSERDA Building Energy magazine, the existing buildings issue. And when this presentation gets shared, it's actually linked, so you can click on that photo to access the article. And that's it. Thank you so much.
Amazing. Thank you so much, Ashley. This was great, full of detail, went into cost data, which I think is one of the great things that we're getting out of the NYSERDA BOE program, is really kind of open sourcing that information, not just the cost data, but very excited about the occupancy data and the ongoing monitoring and performance to really see what this is doing in real life. And I'm curious and have my own questions, but before we dive into the Q&A, Shefali is going to share some events coming up in the accelerator community. Shefali.
Thanks. Just setting myself up here. All right. Yes, thank you so much for a fantastic presentation. So just a few events and announcements to share. Recent podcast episodes, our recent Passive House podcast episode features AZ Rashid of Barrett London. Click the link in the chat to listen. Live event next week, Field Notes Summer Lab Report. Join us next Wednesday during Climate Week for a special session featuring reports from Reimagine Buildings Summer Labs. We'll dive into some of the biggest questions facing high-performance building today, directly from practitioners who have spent the season debating, testing, and learning together, and share practice-based insights you can apply to your own work. Massive Passive, which is this Friday. Reimagine Buildings Massive Impact is this Friday. It's 4 hours of real projects, proven strategies that you can use, from small retrofits to the tallest passive house projects. See what's working now and how to make it work for you. Link in chat to register. And of course, Carmel will be presenting, so we hope to see you there. Some community events. Regenerative Metropolis is next week on Friday, September 26th. It's in person in New York City. Proves to be a really exciting, I was just looking at the agenda, and it's going to be a really exciting day. FIASCon is in early October in Milwaukee from October 6th through 8th. And Building Science Symposium is October 7th in person in Philly. And finally, a quick overview of Reimagine Building Collective events. We'll continue today's conversation next Friday. Also during Climate Week, who doesn't love a Climate Week AMA, with Ashley. So you can, if you have more questions or if you want to continue this conversation, please join us then. And then I'm excited to announce the new cohort is starting this fall in collaboration with Parsons Healthy Materials Lab, who recently celebrated 10 years of doing really great work of making sure that we're paying attention to indoor health and the materials that we use as much as we care about energy consumption. And with that, a quick overview, I'm going to hand it off to Zach for a quick thank you of our sponsors.
Yeah, thank you, Shefali. We want to take a moment to thank the fine organizations that make our work possible here at Passive House Accelerator. So first, a big thank you to our stakeholder partner, NYSERDA, who we've been hearing a lot about today. NYSERDA is the New York State Energy Research and Development Authority. So a big thank you to NYSERDA. Thank you also to our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Partel, Rockwell North America, and Zola Windows. Thanks to our champion sponsors, Bewizo, Cascadia Windows and Doors, European Architectural Supply, Facro, Icon Windows and Doors, Intelligent Membranes, LG Air Conditioning Technologies, and Source 2050. And thanks to our patron sponsors, Building Type, Brennan, Holstrom System, Inotech Windows and Doors, Lamelux, RDH Building Science, and Standards in Sustainable Design. Thanks, sponsors.
Thanks, Zach, and thanks sponsors for making this possible, and thanks community for being here and asking such great questions. Steve and Stuart, if you are ready, I know you had a few questions, and feel free to pick one or squeeze in as many as you can.
Yeah, thank you so much, Ashley. That was an amazing presentation, and it really struck a lot of, it really resonated with some of the work that I've been doing. My question about the Sandon water heat pumps, we had a project on the books for our adult care center, a 112 bed unit, and 35,000 gallons of propane a year to heat 10,000 gallons of hot water per day. We had an excellent design team design it. They had some tricky issues, but bottom line, by the time COVID was over, the price doubled, and our county legislature said, we're not doing that. So I'm really curious as to, you know, were you ganging, or how many Sandon units did you have to gang together? What was your hot water gallonage that you had to meet per day? And how did you do that?
These are all such great questions. Unfortunately, I am not the mechanical designer, and I don't have that level of detail available to me right now. But if you follow up with me, I'd be happy to get you that information.
Okay, great. Thanks so much.
Stephen, you can ask Ashley at the AMA session.
Oh, yes,
Absolutely.
I will.
Yes,
Yeah,
I'll have
yeah.
it by then.
Okay, great. Thank you.
Thanks.
Great. Thank you, Stephen. And Andrew Fowler is up next. Andrew, are you still with us and able to unmute? If not, I can ask the question. Okay. Andrew asks, what were the Energy Star and NGBS ACH levels for the blower door tests?
So for the unit blower doors, it was 7 air changes per hour for this project. And same for an NGBS, they defer to Energy Star.
Great, thanks. I'm going to steal a question spot, and then I'll hand it back over to Shefali to get through the rest of our on-deck questions. I was just curious, you mentioned the training and the building trust on site. Did you do the training kind of in-house as New Ecology, or did you partner with other folks, and how did that go?
We had, because New Ecology is based in Boston and I'm the only person in New York, we partnered with a local verifier, Kevin Stack, who was much closer to the site. You know, I'm about an hour, he's only 20 minutes. And so he was there almost weekly for the first few months of construction to really make sure that everyone was on board, on the same page, knew what he needed to do and what he was going to test and verify. And then he kind of reduced down his site visits until he was back on site testing.
Great. Stuart, I see your message that I can circle back to you to the end if there's time. So George, I see that you have 2 questions. Are you still on? Do you want to unmute and ask your questions?
Yeah, I'm here. The one question is just the net zero carbon. It sounds like that's just operational energy met by the renewables. So
That's
not
correct.
embodied. Okay, yeah. And
Yes,
then I'm sorry.
Sorry, we did do an embodied carbon calculation to show the reduction of using an existing building versus building completely new construction, but that was not 100% offset.
Okay, cool. Awesome. And then by the way, fantastic. I love the vertical stack, sequential, wow. Occupied building, that's amazing. The IFA siding was that like a wrap around the existing, or did you peel off? How did that work? What's the assembly?
We did remove the facade on the existing, and the EFIS is a pre-packaged panel that gets lifted up and attached to the existing structure. So we did have to remove some of it. Some of it remained, but it was essentially adding the panel on the outside and then insulating internally as well to get to that R value.
Cool. Who made those panels?
That is a great
Oh,
question.
that's fine.
I don't
Extol
know.
maybe, or okay, that's fine.
Yeah.
No problem.
George,
Thank-
it sounds like you're saying you're going to attend next week's AMA so you can really
Yeah, yeah.
drill down and get some of these
I'm taking
details.
notes. I'll get these answers.
I'm coming. You better be ready.
Nandini, are you on? Do you want to
Yeah,
unmute now?
I'm here.
Okay.
Yeah, I was just wondering what was involved in testing. You said you tested each unit for the
Yeah,
air. Yeah,
absolutely. And just
and
for
like
George, I want to point out that Josh replied in the chat who the manufacturer was of the panels. But sorry, continue your question.
oh no, just I heard that between apartments are usually porous or shouldn't be.
Yeah,
But how do you go about
absolutely.
testing?
Yeah, so the blower door test that we've mentioned a couple times here is essentially testing the amount of air that is leaking from a single apartment, be that leakage to the exterior or leakage to the units on either side or the hallway. So you isolate that unit, you put a blower door in the opening, and you essentially either blow air into the unit or pull air out of the unit and measure how much air is leaking through those all 6 sides of that box. And you want to reduce that down as low as possible in order to maximize the efficiency of the building. So you're not losing that heated and cooled air. You're not losing the ventilated air. You're not sharing smells and contaminated air from one unit to another. You're creating a singular ecosystem within each unit. And so we did a blower door test in every unit. We also tested the duct leakage to make sure that the ducts weren't leaking. We weren't losing energy that way. We tested the water usage to make sure that each fixture was operating as designed. And we inspected the insulation and make sure that everything is basically constructed per the design requirements.
Yeah, thank you. I didn't realize the air was tested between units as well. All right, thanks.
Stuart, it looks like we have time for you to ask your second question. I mean, sorry, Stephen. Wow, sorry.
Yeah, that's okay. That's a very common problem with my name. 2 first names and 2 last names, and they can both be spelled differently as well. Yeah. So Ashley, I was wondering. I didn't hear anything, but I heard the term resiliency and passive survivability, and I'm wondering if there has been any incorporation of either battery energy storage system or a smart battery or anything like that within the project that would also help allow for sheltering in place in the event of a power outage.
We did consider a battery at the time. Given the cost and COVID issues, we weren't able to switch to a battery, but there is the only gas source on the site is our generator. And so that's our dual backup so that we don't have to rely on electricity during a power outage.
Okay, so that's what gives you the resiliency and the ability to shelter. Great. And I really love that you were able to give the code enforcement officer on the job training with that blower door testing. That's so cool.
It was a good experience. Absolutely.
Yeah, that's the goal, right? Is that like someone who's not really intimately involved in the project comes on site and learns something and is so excited that they want to bring it forward. So that was really a great kind of moment. I hope people people there aren't like, there's this one code examiner who really insists on doing a blower door test and he comes with his own equipment. But you know what, I think we all say this, and Carmel may have put this in the chat earlier. It's like it's just good when code catches up to what we want to do and what we want to see and continues to push us forward. It looks like Josh had a clarifying response on the panel. But that information is in there, George, if you want to see. Great. So our last call for questions. If you want to unmute and ask, please feel free. Otherwise, we're really happy to end early. I'll give it a minute, and I will just say that I'm sure I'm not the only one who is trying to frantically wrap up a BOE application that is due in 2 hours and 11 minutes. So
Not that you're counting.
no, not at all.
Well, we're happy to give time back. I will selfishly jump in, and because Josh's clarification about phase 1 versus phase 2 reminded me of my question, and that's again on the monitoring side. Is Rome Housing Authority looking at Colonial I versus Colonial II now? You know, the 2019 renovation versus this much more high performance renovation, and kind of comparing notes.
Yeah, absolutely. We actually recently got some funding for us to do that comparison and calculations, because unfortunately it's not so simple that it can just be done in a couple of hours. So we're hoping to get, once we have those full 2 years of data, to do that comparison and have even more to present on those two.
Excellent, exciting stuff. Well, I don't see any more questions coming in the chat, Shefali, but I do see a very clear.
Oh, Arda, you have a
Oh,
question? Go ahead.
Arda, sure.
Yeah, thank you so much. I'm just wondering, did you monitor the energy consumption or electricity consumption of each unit individually?
Not individually, no. It's centralized metering, and so it would be too expensive to have sub-metering on each unit. But we will be able to make some assumptions and do some calculations to get down to that level of information.
So did you then, when you were doing sub-metering, did you sub-meter the whole level? Like based on the equipment, let's say electric baseboard, you don't know how electric baseboard it is, but let's say based on the central heating, HVAC equipment and the plug loads. I'm just wondering, how did you do the sub-metering, like based on the building loads, or was it just based on a floor level or a central plant?
Yeah, so right now it's purely at the meter level. So there's 2 centralized meters that have all of the equipment on them. But we will be able to do some calculations again to kind of pull out domestic hot water use versus heating use once we have the full data.
Okay, cool, thanks.
Great. Well, other than our field trip to Hillsdale that is getting organized in the chat, I think this has been a great session, great questions, some continuing conversation at the AMA on the 26th. And with that, hope to see a lot of you on Friday for the Massive Impact Reimagine Buildings online conference. Ashley, Wisse, thank you again so much for sharing this project with us, and looking forward to ongoing data out of the project.
Absolutely. Thank you.